Hello everyone, welcome to another UConn progress video update. My name is Louis Gett. Today we are on the new Engineering and Science building. It is May 3rd and the last time we were out here was sometime in early March. So I'm going to take you through some of the more noticeable updates since the last time we were here. So most noticeably, last time we were here, the foundations had just begun on the south wall, and today you can really get a good idea of the shape of the building. All the foundations are complete except for this one section of shear wall that we'll go into in a little while on the east side. There's two locations of shear walls on this building, brace frames we call them. One is this one section over here to the west, and the other is this huge set over by the elevator. The hole that you see over there is for the elevator pit, and this brace frame is a cube section in the middle of the building that goes up 5 floors. So what a brace frame is, think of it as kind of like a house of cards that doesn't have a lot of structural support. So it's a set of columns, a square cube that travels up through the building that has brace frames that come down to it, that gives it the rigidity to what we call the shear to keep the walls solid and in place. So we also get a chance to take a look at the two forms of construction over here. From this side over here is a full basement. You can see the 4 columns, and I understand there's 5 columns outside this section. This is going to be a slab on grade that ties into this section over there. And that was because there's more rock that we noticed earlier down below, and some utilities in this area. So the electrical room, we're going to get a closer look at that. The utility tunnel off to there. The holes you see on the southwest corner and northwest corner are for the steam line to come in. So this is exam week this week. Next Monday, exams will be over, the students will be gone, the crane, the steel will begin, and they'll be able to start their erection in through here. And then backfill will be able to commence. So we can't really do a full 100% backfill on this type of construction because there's no support for the tall concrete walls. So they need to get the columns in. You can see the concrete box outs for where the beams cross over. There's intermediate interior columns, 2 rows. You see one to the south, one to the north, and they support the structure that goes across and the beams that tie into the foundation wall. So the steel goes up, and then they will be able to backfill. So great progress since the last time we were here. So this is a great opportunity to see exactly what we were talking about and why beforehand. You see, one of the original videos we talked a little bit about the shotcrete and the soil nailing to hold the walls up pretty much straight up and down, rather than excavating much further back out. And now you can see how and the reason for that. And here's the foundation walls are now complete. We're actually looking at the place where the roadway was down into the basement. You can see actually the sides of the banks where the travel passage. We actually walked down to that in one of our earlier videos. So an opportunity to see the foundation at footing level. There's some stone over the top of the footing trains and drains right through there. We'll take a walk down there. The blue hoses are what we call well points to be able to keep the water table down a little bit lower. So an update on the tunnel. We've been over through here before. You can see they formed up to the side, so the actual waterproofing membrane gets placed down in the bottom ahead of the concrete. So they're getting prepared. The waterproofing membrane is in here. Then they'll cast the slab, build the walls, and tie it back in. So we're now entering into the basement over here. We're in the tunnel section on the west side. You can see the giant sleeves in the foundation for the steam line. It was actually in this location that was moved over and eventually will pass back in through the building. That will actually serve the building. So what we're taking a look at here is the brace frame. There's 2 sections of shear walls for this building. It's like a cube section in this right here, the shear wall location. So this was a massive pour. This hole that we're looking at over here is the elevator pit. So I understand this was a couple of pours and almost 400 yards of concrete. So when we say brace frame shear walls, this is like a cube in the center of the building that has diagonal braces that go back and forth onto it that provides the rigidity to the structure all the way up. So this design has two locations here, one here, and actually, to be honest, take a quick look, these bolts are 2¼ inches thick, and there's actually another set down a little bit lower on the edge of the elevator pit down below there. And the second shear wall is all the way over onto the east side, and you can see they haven't even cast. It's the only wall on the foundation that's not cast yet because the steel has to be set, and there's some diagonal bracing that actually gets cast into the wall. So outside of that wall that's not cast until the steel gets up, all the foundations are completed. They need to wait for the steel, and I understand this is exam week here, and after exam week the crane will be able to come in, make some noise, and they'll erect the steel coming up May 9th plus. So we're over here, a little closer look on the east side to the last shear wall, and again the huge bolts where the columns have to be installed, the diagonal bracing that gets cast into the walls, and that's the reason why the walls aren't cast, because the steel has to be installed before that. So we get a chance to look at the classic waterproofing on the exterior of the building. We have the membrane, and then we have 4 inches of rigid insulation, then we have the drainage board that goes over to the top of that, and then there's a footing drain that even goes on actually on the side of that also. Side here we'll talk a little bit about the way this building was constructed. The foundation stops here. This is the shear wall we just talked about, and then it actually continues. There's 5 more columns, what we call slab on grade. You can see the footing that's up in this higher elevation over in here. So the building continues over to the east and continues up 5 stories, and the foundation most likely wasn't carried over into that section because of rock, because of utilities, because of they had plenty of space and didn't need to carry it that way. So we have 2 different kinds of construction that you'll never know the difference when you're up onto the first floor. We have a foundation basement and a slab on grade, and slab on grade really means exactly that. The finished floor level will be the same across there, and it's on grade. Well, we'll take a minute and talk a little bit how the framing is going to be erected. So there's 2 rows, just so that you can see. There's 2 rows of columns. There's a row of columns here, and there's a row of columns there. So the columns will come up, and they'll support the beams between that column and the north exterior wall. Then the beams will run from column to column, and then the beams will run from column to the south. And that's where you see the pilasters come up over to the top over there, the bolts over to the top, and that's how the framework is closed off. So it's a unique opportunity. The next time we come down, the steel will be erected, and you'll never get this visual again in the life of the building. So we'll take a quick panoramic to finish our video to be able to capture this particular look ahead of the steel. So thank you so much for joining us in this new engineering and science building project update. Remember to subscribe to our UConn PAES channel. Once subscribed, on the left-hand side, manage subscriptions. To the right, the gearbox symbol. A check next to send me all notifications for this channel with the save. Now, anytime we add a project, update a project, you will receive an automatic email notification. We thank you for your interest in our UConn projects. Have a great day.